Okay, buddy? Try that one. You should, by now, be able to complete your drawing. You should be able to do formula, substitute, simplify, solve, get an answer, and reduce your answer, exact answer and approximate answer. Don't do it on your calculator. Write it all out. Make it nice and neat. So, Sandra, do the problem. Don't play with your calculator. Doesn't do you guys any good to go to tutoring if you don't know anything to start with. Do what you're supposed to do in class, and then you won't have any trouble. Got it already? You said, oh, you're fast. Mistake though. It's not 14. 16 was correct. You guys are going to hate 48. 48 is one of those special ones that everybody gets messed up on. Do you see that 4 goes into 48? But so does 16. 48 is one of those killer ones that are hard to remember. 48 and 98, got to watch out for it. Yeah. 48. Now remember, that's b squared, that's not b. Yeah, you need to finish. Yep. This one is A, this one is C. Remember that the hypotenuse is always across from the right angle. You need to substitute. Yes? And 16 goes into 48, guys. Don't forget. 16 is the tough one. A squared plus b squared equals c squared. Oops. Okay, I'm going to put in my 4 for A. What about B? What should I put for B? B. And for C? A. That is 16 plus b squared equals 64. Subtract 16 from both sides, and b squared equals 48. Now, when you take the square root, this is important. Don't just write b. This is actually b squared. You still have to solve it by taking the square root. Now, b is approximately, well, it's exactly equal to 48, isn't it? Sorry, square root of 48. Now, isn't that really close to 49?
Yes.
What would it be if it was 49? B would be 7. So this is almost 7. It's about 6.9, isn't it? Can everybody see why?
6.9.
Look, 49 is 7 times 7. Since this is 48, it's really close to 7. It's a little bit less. 6.9 or so. Now, when we want to find an exact answer, we're supposed to find the perfect square factor, which in this case is 16, not 4. Does everybody see that 4 is 4 times 12? But you see that 4 goes into 12?
Yes.
So what is that? That is 4 times 4 times 3. Does everybody see that there's a 16 there? This is just a way of looking for it. Now, if you remember that this is 16 times 3, it's easier. And that is the square root of 16 times the square root of 3, which is
4, 3.
4 square root of 3. That's the exact answer. Approximately 6.9, right? Now I have some interesting news for you. Everybody look up here for a second. This problem would literally take me about 3 seconds to do on an SAT test. The reason that you need to be very quick is because you don't have time to do all this. Let me show you why. This is called a special right triangle. There's only two. There's this one and one other one. Let me show you why it's a special right triangle. This is an equilateral triangle. 8, 8, and 8. Everybody see that? When you cut an equilateral triangle in half, you get a special right triangle. Equilateral triangles have 60, 60, 60, don't they? This is 60, and this is 30, and this is a very, very important right triangle. You guys are going to learn this one and one other one. You have to memorize them. The good news, this is always double that. Can you see why? Hey guys, this number is always half of this number because it's half of an equilateral triangle. See that?
Yes.
This angle is always 60. This angle is always 30. This angle is always 90. The good news, this one times the square root of 3 is always this side. It always works out like that. You take that number times the square root of 3 and you get the height. You're going to see this number over and over and over again because it's one of your special right triangles. You have one other one. Yeah, you're going to keep it. Yeah, you're going to keep it. Next time in class, you're going to turn in your test, and hopefully you'll have it right. This is the other special right triangle. It is called the isosceles. This side is going to be 4. This side is going to be 4. And then we're going to find the missing side. Yes. This is extremely important for next semester, guys. Next semester, you're going to be working with these triangles and these. And you have to be able to do them instantly, in your head, immediately. There's only one way to get good at this. First, you have to do it the long way, but eventually you have to cut it short. You have to learn the shortcuts and know why they work. Substitute, simplify. Don't forget you have to label your diagram. What is this sign over here? C. And A and B are the legs. Substitute, simplify. Go for it. I'm going to let you guys finish this one, and I want you to reduce it when you get an answer. Make sure that you get the reduced version for C. And this is the question. There's only one question I want you to ask yourself. For the next 2 days, I want you to see if you can understand why this works out the way it does. You're looking for why do you get what you do for C. Figure out what it is. By the way, do you know what these two angles are? They're equal.
Yes.
So what are they? Yeah. What are they? This is 90.
No, el número.
No, it's isosceles, but what are these two sides? 45. That's right. 45 and 45. This is your other special right triangle. Now, for those of you who want to actually go on and graduate and go to college and that sort of thing, I want you to really think about why you got the answer you got for C. This is a very tough question. But think about why it works. Maybe do some other examples with the same, like the numbers are the same, and see if you can see why C works the way it does. If you can get that, see if you can see why this one works the way it does. This one's way, way harder to figure out. You're going to have to figure this out eventually. What'll happen is, if I just tell you, you'll forget it in about 10 minutes. If you figure it out for yourself, you'll remember it for about 10 years. There's a huge difference between the two. The assignment from the textbook, if you want to do it, page 466, 2 through 36 even. Yeah, if you want to do it, you can check out a textbook.